Hello, welcome back to my YouTube channel. I'm Xavier Smith, and today I'm going to talk about the centers of a distribution. So this is basically what kind of distribution do you have, like what is the shape of it, and then what do you use for the center of that distribution. So let's get started. I'm going to say there's two types of distributions. Either you're roughly symmetric or you're skewed. It's one or the other. So I'm going to give you a couple ways to see if it's symmetric or skewed. First of all, if it's roughly symmetric, it'll kind of look like this bell curve. It'll have the same amount of data points on both sides, right? But a good thing to check if you have summary statistics, or you can get it on your calculator, check if the mean is approximately equal to the median. If they're close, you decide what close is. You're like, okay, it's roughly symmetric. If there's outliers, it's probably going to be influenced both ways. If there's a high outlier and a low outlier, it could still be roughly symmetric because the mean and median could be super close. But in this distribution, a roughly symmetric distribution, use the mean because we know all the points are pretty close together. There's no high outliers, no big tail to one side. So the graph isn't pulled to either side. So the mean will give a good average of the points. Now, when we go to a roughly skewed graph, this is left skewed if you couldn't tell, we are going to have the mean, if it's left skewed, the mean's going to be less than the median because the median's just the 50th percentile, the middle point. So the middle point will be somewhere here, right? But the thing is, the mean is counting all of these little values, and then also this big value, and then this little value. So since there's a big tail going this way, all those values are counted in, and each of these values is bringing the mean down, while the values over here aren't really bringing the median down. And then if you have a right skewed graph, it's going to be the other way. It'll be the mean is greater than the median because this big right tail would be just every point is just increasing the mean while the median's not changing too much. So the thing about skewed graphs is if there's also an outlier, what a median is called resistant. It is resistant to outliers. So if there's an outlier way over here, right? Roughly skewed, you would use median because outlier, well, it's going to drag the mean with it, right? So it's the same thing with these tails. They're not always outliers, but they're dragging the mean with them. So you want to use the median to get a good representation of the center. All right, so just overview. If you have a symmetric graph, use the mean because all the points are pretty close together and it gives a good average of the data. But if you are using a median, well, if you have a skewed graph, you'll want to use a median because it'll give a better description of what the middle is while there are tails dragging the mean. So the mean won't be roughly equal to the median. And also, if you just have summary statistics and not a graph, you see the mean is way bigger than the median, you're like, oh, this thing is right skewed. Or there's a high outlier, which you'll see from the max and min. And if the mean's way lower than the median, you're like, oh, this thing's left skewed. But if you see in the summary statistics, ooh, mean and median are really close, you're like, that thing's probably roughly symmetric. That's cool. All right, one important thing to note, on the AP test, you can still get points for if you have roughly symmetric, well, if you have roughly skewed, you can still get points for using mean. Just make sure if you're comparing distributions, you use the same value for both. You're using mean for both. So if you have a roughly symmetric data piece and one is skewed, then you have to use the same for both. You could use mean, probably not the best. It would be better if you used a median for this. It'll show higher understanding and maybe your grade can get bumped up. If they're on the edge of bumping you up to from a 3 to a 4, maybe they'll bump you up just because they're oh, they know a lot. Okay, so thank you for watching this video about centers of distribution. Please like and subscribe if this was helpful, comment any questions, and thank you for watching.